Good afternoon, students. Today we are going to discuss the subject Signals and Systems. Subject code is 18EE54 by Professor D.A. Vennila. In this, we are going to discuss Module 1, Introduction to Signals and System. First, we are going to see the definition of signals. Okay, we are going to see the definition of signals. What is meant by signal? A signal is a function of set of independent variables. Okay, a signal is a function of set of independent variables. A signal in general carries some kind of information available for observation, and also here we can say the definition for signals. A signal is a mapping between the independent variable and the dependent variable. Okay. So what is meant by independent variable here? Independent variable is nothing but time, position and frequency. What is dependent variable? Dependent variable is nothing but the example for is audio signal, video signal. Okay. This is some system I have given. Okay. So here system, how we are going to define a system? Here we are having one integrated circuit. Okay. An integrator which is shown here, which transforms the input signal. Input is voltage, which is represented as Vi of t, to output voltage V naught of t. The mathematical model of the physical process that relates the input signal to the output signal. Generally, if you say system is nothing but the input will be given to the system will perform some operation on the input to get the desired output. Here the input is x of t and output is y of t. The output y of t is equal to t into x of t, where t is nothing but your transformation. Okay. Now we will discuss the classification of signal. So here the signals are classified into continuous time and discrete time signals, analog signal and digital signal, even signal, odd signal, periodic signal and non-periodic signal, deterministic signal, random signal, power signal and energy signal. We will see the definition of signals one by one. First we will see the definition for the continuous time signal. The continuous time signal is nothing but here the amplitude is continuously varying with respect to time. Here at 0 we are having one amplitude, at 1 at time t is equal to 1 you are having one amplitude, at time t is equal to 2 you are having one amplitude. Like that, a signal which is continuously varying with respect to time is said to be continuous time domain signal. And the next one is discrete time signal. Signals that are defined at discrete instant of time. Okay, here you see at discrete instant of time only you will have the amplitude. At 0 you will have amplitude 3, at 1 you will have amplitude 2, at 2 you will have amplitude 1. So here a discrete signal is nothing but you will have the amplitude only at a discrete instant of time. Okay. In continuous signal, every point is defined, but in the discrete signal, only particular point only defined. Okay, that is the difference between discrete signal and continuous signal. Next, we will see analog signal and digital signal. Analog signal will be defined as a continuous signal which can take any value ranging from minus infinity to plus infinity at every instant of time. Okay, so here no discretizing amplitude. Digital signal means digital signal will take a discrete value at a discrete instant of time. We must discretize amplitude. And the next one is even signal and odd signal. Even signal means nothing but a mirror image. Okay, so even signal is nothing but a mirror image. So whatever available on the positive side, same thing will be available on the negative side. So here you see here you will have at 0 you will have amplitude 1. So at 1 time t is equal to 1, what is the value of the signal? 0. At time t is equal to minus 1, what is the amplitude? Here it is 0. At time t is equal to 1.5, the amplitude is minus 1. At time t is equal to minus 1.5, the amplitude will be 1. Okay, so like that, the signal whose amplitude is same at minus t and plus t instant of time. The signal whose the signal whose amplitude is same at time instant minus t as well as plus t. Okay, so this is also called as a symmetric signal. Okay, so and what is the formula for even signal is x e of t is equal to 1 by 2 x of t plus x of minus t. And the next one, what is odd signal? Odd signal, a signal whose amplitude will have reverse amplitude at reverse instant of time. Here at time equal to 1 you will have 0, at time equal to minus 1 you will have 0, but here your amplitude will be reversed for reverse instant of time. See at see for example here at time t is equal to 1 you will have amplitude plus 1, at time t is equal to minus 1 you will have amplitude minus 1. Okay, so here what is the formula for this one is x naught of t is equal to 1 by 2 x of t minus x of minus t. So this is the difference between even signal and odd signal. Okay, so here we will see some of the problems which is related to even signal and odd signal. Now this is the first question they given. What is the question here? It is find the uh, even and odd components. This is the problem. Here they given x of t is nothing but your signal. It consists of sine and cosine. That x of t is equal to sine t plus cos t plus sine t cos t. Okay, find the even component and odd component. So now already I told the formula for even signal is x e of t is equal to 1 by 2 x of t plus x of minus t. X of t it is given here. So no problem, as such you are going to take x of t. Okay, and next what you are going to substitute? Substitute t is equal to minus t. Okay, substitute in this given equation. Substitute first one, what you are going to do? We are going to substitute t is equal to plus t. Second one we are going to substitute t is equal to minus t. Now t equal to minus t I substituted. If I substitute t equal to minus t, sine of minus t is minus sine t. Cos of minus t is cos t. So here sine of minus t is minus sine t, cos of minus t is cos t. So if you multiply sine into plus minus. Okay, so now I'm going to substitute in this formula. So xc of t is equal to 1 by 2, that is x of t sine t plus cos t plus sine t cos t plus minus sine t plus cos t minus sine t cos t, that I'm going to substitute here. So all after cancelling this one, now I will get only cosine cos t. Okay, I will get cos t. This is the even signal. So here we can identify this sine and sine cos both are odd signal. The cos is the even signal, that we know, but problematically you have to do this one. And the next one is we have to find the odd component. Odd component formula we know that x naught of t is equal to 1 by 2 x of t minus x of minus t. Okay, so the same thing I am going to substitute. So here what I told here, x naught of t is equal to 1 by 2 x of t minus x of minus t. So this value if you substitute here, this x of minus t, outside minus sign is there. If you substitute here, it is plus sine t minus cos t plus sine t cos t. So you will get cancelled. The remaining part you will get the sine plus sine t cos t. Okay. Now same they have given for the another graphical representation problem. So this problem you have to find the even component and odd component. Okay, even component and odd component. So this is the first question they given. So this amplitude is 4 volt and the signal exists time period from 0 to 2. So now I want to find the even signal and odd signal. What I told, even signal is nothing but your mirror image. Okay, so whatever this side is there, the same thing will appear on this side. That is nothing but even signal. Odd signal means whatever is there. Odd signal means whatever is there in this side, that will be appear on this side. What I'm going to do, this signal I'm going to fold with respect to y-axis. So if I fold this one, this will come this side. So this will be making as a center, like your notebook you take, the notebook center part will be there. No? So this will be folded this side, so you will get this point. So if you add this two signal, so what is this one? 1 by 2 x of t. X of t amplitude is 4. So 1 by 2, 4 plus 4. So you will get the amplitude, total amplitude 2. This is the even signal. Okay. The next one is odd signal. Odd signal, how you are going to fold means you are going to fold this signal with respect to x-axis. Okay, you are going to fold this signal. Which one you have to fold in the sense the previous one you have folded, no? So that you have to that is the folded signal, event signal, folded signal that you have to fold with respect to this axis, that is time period. Okay, and you are going to add this two signal, that is x naught of t is equal to 1 by 2 x of t minus x of minus t. X of t amplitude is 4 and y of t amplitude is 4. So 2 divided by 2 you will get 4 divided by 2 you will get 2. Okay.